All right, example 2, add 10 elevenths minus 5 sixths plus 1/3. For me personally, I'd like to get a common denominator for everything all at once. I think it's easier. Anybody have an idea what the common denominator of 11, 6, and 3 is?
33.
33 works for 3 and 11, but not 6. 66 works for 6 and 3 and 11. So there it is. All right. Now, if you want to see a way to get a common denominator, look at the prime factors of each of these guys. You have 11, which is just 11, right? It's a prime number. 6 is 2 times 3, and 3 is just 3. All right. The greatest common, or the least common denominator is every single thing that occurs in anything. So 2 occurs, 3 occurs, 11 occurs, each to its highest power. So 2 to the first, 3 to the first, and 11. If this was 3 squared, you'd have to go 3 squared. All right, so whatever the highest power you see is what counts. Multiply them up, 2 times 3 times 11 is 66. That is a technique for least common denominator. I only use that when I can't figure it out right away. Most of the time, I've been doing fractions since 5th grade, I can look and see. But if you get to a point where I can't figure out this least common denominator, that's a way of doing it. Now, what I do with fractions, I keep fractions usually horizontally positioned on my paper, is I go ahead and rewrite the problem with common denominators in place before I write the numerators. Okay? So I go ahead and pretend a common denominator exists for all 3 numbers. The common denominator I want it to be, which is specifically here 66. Then each problem is a question and answer session. What was the denominator? What did I do to make the new denominator? I have to do the same thing to the numerator. So what did I do to 11?
Times 3.
Times 6, right? 11 times 6 is 66. So I have to do 10 times 6 is 60. Okay? I have to multiply this one times 6 because it's times 6. The second one, what do I have to multiply by? 11. All right, so I have to multiply the top by 11. And the third one, what do I multiply by?
22.
22, so I have to multiply the top times 22. Each individual fraction has to be modified based on what its denominator was. So just because you multiply the first one times 6 doesn't mean you multiply the second one times 6. So each one has its own fix. You have to fix it correctly for each one. Now, I've got pluses and minuses going on here. Order of operations dictates that you're supposed to subtract and add from left to right. Okay? We haven't dealt with signed numbers yet. We're going to deal with those in chapter 5 and 6. I think you've dealt with them before. But if this said 55 minus 60, that would make a negative 5. We'll pretend, since we haven't dealt with signed numbers yet, we'll pretend we can't. Okay? So what I would do personally is I would go ahead and add up my 2 positive ones together. Oh, minus 55 is 22. All right. So 60 and 22 makes 82 over 66 minus 55 over 66. And then 82 minus 55 is 27 over 66. All right. Obviously, 60 minus 55 is 5 plus 22 is also 27. It works left to right in that case. But again, if it's 55 minus 60, we haven't learned about some negative numbers yet. So let's just pretend we haven't. So that's a safe way to make sure that doesn't happen. Notice that at no point in time did that bottom number change. Once I got a common denominator created, it's over 66, it's over 66, it's over 66, all the way through to the end. Now I'm at my final answer. I got to look at that possibility of reduction. Can I reduce this fraction? What does it divide by?
3.
Divides by 3. And again, going back to this whole idea about least common denominator, if you can figure out that it goes into something, or something goes into it, go ahead. But if you can't, again, that prime factorization thing. 3 times 3 times 3, hey, 3 goes into 66. All right, so if we try that out, divide 27 by 3, you get 9. Divide 66 by 3, you get 22. 3 only goes into 9. 3 doesn't go into 22. It doesn't reduce any further, so that's the least reduced answer that we can get to that.